Okay, cool. Today's stream we're just going to be doing some leak code, some grinding for an interview that I have soon. It's pretty late, it's like 2 a.m., but I can't sleep, so we're just gonna do leak code problems. Also, if you are watching this live while I'm working on them, you could use the command exclamation mark brandalyze, because I've been working on a project and it's going to be up soon, so the waitlist is available on the link, and also I'll have the link in the description and the comments, or yeah, in the comments later if you wanna take a look, so that would help a lot. Yeah, so getting into the stream now, we're just gonna do the Microsoft Microsoft company wise problems, and just see how many we can get done before I get tired. Okay, cool. Okay, we'll just start off easy and work our way up, like the ones that I know I can solve, because I haven't done these in a while. Cool. Let's just reset here. I'm logged in, right? Cool, I am. Well, if it's just a Java, I just might have to, just reset real quick. Okay. Don't need this. Oh, and also I got a new mic recently, so I don't know if it sounds good. But I'm hoping it does, because it was expensive. Okay. So we're given an array of integers, nums, and an integer target return indices of the two numbers such that they add up to target. Yeah, okay, so you must assume that each input would have exactly one solution. You may not use the same element twice, so we can return in any order. Basically summed up, that means we have an array. So we have an int array, nums, and what we'll be returning is an array with two indices, so I1, I2. Nums, I1, I2. You want to say that only valid solution. And we're not using the same element twice. So we know that the brute force solution is to just use two for loops. Is equal to 1, j. I equals out straight after I. Less than. And return of I and j. Or you have to return an array, so it'll return an empty array. Yeah, so that passes. And yeah, so that's going to be all of n squared. So let's see. Force. So we go and let's optimize it. So yeah, let's say should be oven. This is oven time on space. So optimize for space, but not time. My solution should have oven and space. What we can do is even. What we say of the number to the index. So let's see. Num to index. Cool. Then say plus, and let's see if we were to, I guess, start off by adding the elements to the hash map and then handle the conditions for checking for the target after. That would make sense. Or yeah, just check my my mic's a bit laggy. Let me just do something real quick. Change this. Yep, so the mic should sound a bit better. The only thing is that there won't be any noise cancellation, but I don't think that's a problem. I don't think that's. Yeah, okay. So it's a lot cleaner sounding now. So now what I want to do is, okay, so we have iterating from start to end. So we need to actually calculate the difference. So for example, if we have our input like this, so 2, 7, 11, 15, and the target being 9, we know that our answer is going to be 2 and 7. But when we have 2, we need to be able to know that we're looking for 7 as our number. So when we're on 2, we need to calculate the number that we're looking for, being the complement. So the complement would be the number that we are, the number that we have to get in order to get the solution. So it's the term or the variable that we're looking for. So we can do this by saying int complements is equal to target minus nums I. So then we're gonna say we've calculated the complement already, and we'll say if num to index contains complement. Let's see, just return when you each array containing num to index dot get complements and I. But then we'd also have to add num to index dot puts. We'd have to add our rather we have to add nums I and I. So we have to add the number and the index because it's mapping a number to index for each. And then yeah, if we can't find it, we return a new empty array. An empty array. Oh, I forgot, yeah. In Java it's contains key, not contains. Yeah, okay. Cool. Yeah, so that runs. Yeah, as expected. So we've got two solutions, one brute force running in O of n square time, but it's optimized for space, and a hash map solution that runs in O of n time and space. So depending on whether space or time are important, we know that one solution could be used over the other, but that really just depends. Cool, so I'll just submit that there just to see if it passes all the test cases. It does. That's great. Cool, next problem. Yeah, I'll just mark that off. I'm going to use this as like a checklist for myself while I'm working through them. And I might not follow this list exactly. If I feel like I'm struggling on any of the topics, I'm just going to find similar questions on LeetCode and solve them that way. Because I think that's a good way to approach. Okay, the next problem is best time to buy and sell stock. Okay. I've never done this in the dynamic programming way, but I don't think I'll have to. Because I think it's like a regular sliding window or a two-pointer problem. I can't remember. One of the two. But we'll see. Okay, so we're given okay, let's just think through it for a bit. I might actually just open. Alright, can I do this? Yeah. Let's open Excalibur and pull that up there so we can push this here. Just for a bit, I just want to make sure that I'm reading it properly. So we're given an array prices. Yeah, so given prices. Given array prices. We know that prices I is equal to the price of the stock given. Okay, price of the stock given on so we need to choose a single day to buy a stock and choose a future date. A future date to sell. So we're choosing a date to buy and a date to sell. So then we just return the max profit. Okay. Return max profits achievable. If no profits, return 0. Okay, so our first array is this. Okay, I'll start drawing from here, I think. So we're given a 7, 1, 5, 3, 6, 4. So I'll use green to buy, red to sell. So can't really remember how this algorithm is to work, but based off of common sense, I know that you should buy on the lower days and then sell on the higher days, if that makes sense. So what I'm thinking is that we have like before I start using colors, I'll just make both these white. So I'll say we have like a pointer here under buy. So the first two here, right? If that makes sense. So then we check based off of these. So one is going to be a buy pointer, one is going to be a sell pointer. So we'll assume that this is the sell pointer, this is the buy pointer. Or even we could assume that the left is the buy pointer and the right is the sell pointer. So I'm trying to think about how we would do this. Because, you know, obviously we'd want to buy at the first index that we could possibly buy. But then if we can't buy here, then I would want to push our buy forward, if that makes sense. So like, for example, say I was going through it, let me just use a different color, like orange or something, or even yellow. Oh, I gotta get yellow somehow. I can't remember any hex codes. This is fine. Anyway, so say we buy here, we buy at 7, then we see that we're not going to turn a profit if we sell for 1, because that means we lose 6. So then what I'm thinking is, since this is greater than this, we would then set our buy pointer here, but still have the sell pointer moving forward, if that makes sense. So we buy here. I know I'm overcomplicating this because this meant to be an easy problem, but I'm just out of practice. So we sell here, or buy here initially, but we know that this is way lower, so we're going to compare them. So we'd be making -6 here. So then we would make this our new pointer, or our new buy pointer, so that we buy for 1, and then sell again, and then we would keep this at 1, then sell again, then sell again, then sell again until we reach the end, and we'll see which one is the highest, which would be this one. So our difference here is 5, so that we'd have 5 as the final result, if that makes sense. So like in terms of pseudocode, say keep 2 pointers, you buy and sell, start buy at index 0, sell straight after, sell at +1, guess greater than or equal to by, or maybe I'm overcomplicating, but we'll see. Greater than or equal to by, otherwise adjust pointers. We'll say that for now until we get into coding. So yeah, sounds alright for now, I guess. But okay, let's try it out. Okay, so let's say int by equals 0. Say int min, or so max profit equal to integer dot min value, I guess. We'll say for each cell is equal to 1. Cells less than prices dot length cell plus plus. So I want to say if prices by is greater than prices sell, say by I don't know, like should I actually move? Wait. Yeah, okay, I'll try by plus plus first. But I'm thinking I might actually have to just push it all the way up and just say like by is equal to cell. Okay, I'll keep it like this and then we can see how it works. By is equal to cell. And then what else? Let's say max profit will be equal to the max of max profit and max profit and prices by, or prices sell, right? So the price that we sell for minus prices by. And then here we would return max profit. I don't think this is complete, but we'll see. Oh, no way. Okay, so let's test it here. If it runs through all test cases, this should be okay. Yeah, okay. I figured that would be the case. Oh yeah, we said 0 if there's no profit, right? So should I leave that at 0? Because I feel like if it's 0, it's still gonna give the wrong answer. Okay, let's see. Okay, there we go. Easy. Because I was thinking if we did by plus plus, like I was thinking initially, it's gonna stop at certain points that we don't want it to stop at. So it shouldn't. Yeah, it shouldn't. So for example, here. Let me see if I can run through that case on Excalibur. So it's 2121012. So in the case of 2121012. So we start buying up. We buy 1. Or sorry, buy for 2, sell for 1. no profit here. So then we would move our buy up here. So we buy for 1, sell for 2, profit is 1. Oh wait, okay, so no profit. So then we buy for 1. Sell for 2. Our profit should be 1 here. Alright, the answer here. Okay, so yeah, because we're getting 2 instead, because I'm incrementing by. So we have 1 here. And what was my condition? So if buy is greater than price is sell. So we're buying. So yeah, we don't increment here. So then that goes there. We don't increment here. We don't increment here. Yeah, so that we just stay on 1. But if we use buy equals mid, once we get here, right, okay, so 1. Hey, what's up, Aaron? Yeah, so yeah, then we would end up having to, if we set it to buy equals sell, we'll end up basically getting a free stock. So then when we sell it, our profit should be 2, which is why that doesn't work. So it should be buy equals sell. No, there's no problem. I'm just doing leetcode to prep for interviews and stuff. So I knew how to solve the problem. I was just going through a case where it wouldn't work, because I was split between 2 solutions at the start. So I had solved it already, but just kind of making sure I understood it fully. Do you do any leetcode ever? Or, and also, I wanted to ask, what made you stop by the stream? Glad to have you here, by the way. Oh, bad. Okay, so next problem is merge sorted array. A lot of these I've done. Yeah. Merge sorted array. Okay, so this one's a bit harder, because I know there's a special algorithm you're meant to use to make this work. So let's set that up again. So we are given 2 arrays. Yeah, one second. Just want to check if this is on. Yeah, okay, so this should be working, but it's not. It's fine though. Let's try this. Yeah, okay, so that does work. Yeah. So we're given two integer arrays, nums1 and nums2, sorted in non-decreasing order, and two integers m and n, representing the number of elements in nums1 and nums2 respectively. Merge nums1 and nums2 into a single array, sorted in non-decreasing order. The final sorted array should not be returned by the function, but instead stored inside the array nums1. To accommodate this, nums1 has a length of m plus n, where the first m elements denote the elements that should be merged, and the last n elements are set to 0 and should be ignored. Nums2 has a length of n. Oh, interesting. Okay, so let's see. So nums1, let's call it n1. Say, okay, stroke with n1 is equal to 1, 2, 3, 0, 0, 0, and n2 is equal to 2, 5, 6. And we have, so n is 3, so also given m and n. Okay, so m for both is 3, right? Yeah, so m is 3, n is 3. So there's m elements in both, or 3 elements in both, as I should say. So what we want to do is actually swap them, or sort them within nums1, if that makes sense. Genuinely can't remember the algorithm, but that's okay. We could try and derive it, hopefully, if it's possible. If I can't get it, I'll just look up the solution, but it shouldn't be that bad. So we've got 1, 2, 3, 2, 5, 6. So I guess what we could do is just do like a swap. If it was within a single array, I know that we could just take each element, and as long as it's not 0, we push them and move them along. But for a problem like this, let me just put the thinking cap on. So we would do like some sort of equivalence check. So for example, we go, I guess, some sort of loop, either a conditional like for or while loop on both arrays, and then check each index. But once we get here, that kind of becomes meaningless. Okay, I'm just going to quickly check what I had last time to see if it makes sense to me. So we're using, right, okay, so we're using the end of both arrays. I don't want to actually like fully know. So P1 is the end or the last element for here. the last element that we've added here, so index 2, which makes sense. And then this would be index 2 on this array. So we marked off these points. And then this should be index 5, which is here. 0, 1, 2, 3, 4, 5. Okay. Make that one a different color. Okay, so let's go back here. So we should be going while these aren't 0, right? Oh, wait. I marked off the wrong thing. Wait. Oh, no, that can stay undone. This should be here. This should be here. So what I'm thinking is I need to... Might as well turn my camera on as well. Doesn't really make a difference, but I should. Let's see. Is it working? Don't have the lights on really. I have a lamp on, if that helps. I mean, the lamp's not even on, so it doesn't change anything. Okay, let's get back to that. Okay, so it's okay, perfect. Okay, so what I want to do actually is I want to say that we've got each element, the end of n1, the end of n2. So while we're not at the start here, so until we've reached this point on both arrays, we want to keep swapping, right? So we're going to check does that make sense? Right? Let's see. Yeah, so while we're greater than 0, and then on P2, we want to see if we still have any elements in there. Okay, let's say something like, so while we're here, I mean, this doesn't really make sense. So I'm saying as long as here, as long as what we've got here so I'm checking which of these is larger. So we know this is smaller. So what I should be doing is putting that in this index and then moving this down. And I guess I do that and keep checking all the way to the end. In some way, so walking through it, we check 3 and 6. Wait, let me just create the final array, if that makes sense. So we have 1, 2, 3, 0, 0, 0. So we would check 3 and 6, which is smaller. 3 is fine, and it's already in nums1, so we just keep that there. So let me just pretend as if I've added 6 in there. And then decrement the 2, so that we check 2 and 5, which is smaller. 2 stays the same. 5, because it's 2 sorted arrays, right? Yeah, so they're both sorted, so we can just move backwards. 2 and 5, we check 5 should go here. We have 1 and 2, that's where the problem comes in, because we can't just put 2 here. Because that violates this. So that's why I think the condition I put through is wrong. So let's say if I brought this back, went back to the problem, open this up. So yeah, if nums1, p1, meaning if nums1 p1, meaning nums at index 2. Oh, let's bring that back. Damn, I erased it. Okay, cool. It's all good. It's all good. We'll figure it out. So we have int p1 equal to so m minus 1, int p2 equal to n minus 1, and int p merge equal to m plus n minus 1. So that would be 5. And now I want to say while p1 is greater than or equal to 0, and p2 is greater than or equal to 0. Need to make sure that basically comparing the two like we were doing before. So if nums1 nums1 p1 is greater than nums2 p2, then say nums1 p merge. I'm going to set that to, so nums1 p merge would be the last index, would be equal to nums1 p1 minus essentially. So what that is done, essentially we have, I don't want to redraw, but it's fine. I'll take the array. We'll take 3 and 2, 5, 6. Okay, that's fine. We'll go back and do it again. It's making more sense, I guess. Let's go 1, 2, 3, 0, 0, 0. And then an array like this, 2, 5, 6. Just drag that. So essentially we've got the last index of both arrays and the last index of this array. So I'm checking if one of these is bigger than this, as long as we go and then if it's not, we go back, right? Just need to make sure it keeps going the way I want it to. So 6 is bigger than 3. So we set this to 6, right? No, we never put that in the condition though. Right? Right, let's submissions. Because we never put that there. Yeah, okay, that's what I was missing. We say that nums p merge minus, but also I want to make sure of something. So if I go like +1, let's do a temporary real quick. Just need to make sure thing. So seeing honestly here, there's the variable or the variables p merge and p1 updated after this if executes, and by updated I mean decremented, because that's basically what's confusing me. Okay, so they started 5, started 3, like the problem. 3 is copied to nums 5, then p1 becomes, oh, okay. Lovely. Okay, that makes sense. Because I thought that this would just immediately become 4, and then this would immediately become 2, but that's okay. Yeah, let's say else nums 2, or sorry, nums 1 p merge minus equal to nums 2 nums 2 p2 minus. And then if for any reason we still have elements left over in p2, we need to maintain the addition, right? Because we need it to get to being empty. And I'm wondering if we can use it. Yeah, we can use another while loop. So here we go, while p2. Where's that with bin? No, it's not. Okay, that was right. Okay. So while p2 is greater than equal to 0, we need to keep updating. Say nums 1 p2 or nums 1 p merge is equal to nums 2 p2 minus merge. And then should that be it? Because we're not returning anything. Cool. Okay. I wouldn't say that's the easiest that we've ever done. I mean, at some point it is. It might be just because I'm tired as well, but it sounds like an excuse. So I'm not going to use that excuse. Yeah, it was a difficult one. Yeah, but it's done now. It's cool. I guess efficiency wise, it is O of n with O of 1 space, so it's pretty efficient. Can't really think of any way to do this in O of 1, because I feel like you would have to, since they're two sorted arrays, would have to do some iteration over. Yeah, okay, we're good. Next problem. Longest substring without repeating characters. Kind of jumps all over the place. I wish there was some kind of structure. I guess for next time, if I do stream later today or tomorrow, what I could do is like just copy all of the problem names and then organize them into topics, because it would make more sense that way. And that would help, yeah, it would help out a lot, because then I could actually follow with some kind of structure and be in the flow while I'm working, because going straight from an arrays problem to sliding window, sorting two pointers, then straight to linked list, and then linked list, and then trees, tries, whatever. It's kind of crazy, but for now we just work. Alright, cool. Let's do some. Oh wait. Okay, I didn't see it. Yeah, I guess it's the first medium. How long have I been live? 50 minutes? Okay, so I guess if we can get this done fairly quickly, I might try one more, or we just end. And then aim for a longer stream, because I want to get some sleep. Okay, this problem shouldn't be too hard. Okay, copy the example, copy the problem title. Just get rid of that. Look at text box. Okay, that's extra large. So don't know how that always ends up happening. Okay, cool. So what I'm thinking we do is have some kind of set with all the characters, because we don't want any repeating. So like here we have this string. So did I add that H? I did. Okay, let's say yeah, so we have a string A, B, C, A, B, C, B, B. And we have them arranged like this, so we don't go the longest substring without repeating characters, so without any duplicates. So we have to get through the array. If we have a string with any repeating, we kind of have to start the string again, if that makes sense, or get rid of the repeating so we can continue. So for example, we have ABC, that's a length 3, but as soon as the next A comes in, what I'm thinking we do is, until we have none of repeating again, we need to short the string from the left side. So by that I mean we use the eraser here, and it didn't work the way I thought it was going to work. Yeah, so essentially if we do 1, 2, 3 like that, we would have to keep shortening. So then we would have BCA, which is another length 3. But once we've come across this B, then we get rid of that. CAB is a unique string with length 3. Then once we come across this C, we get rid of this. Then we have ABC again, unique string with length 3. But then we come across a B, which is where this comes in again. So while we have this, we need to get rid of this A. We need to get rid of this B. And if we add this B, then we don't have a unique string. So we get rid of the C, we get rid of the B, then we get rid of the B. So then we have a string of length 0. So then in this string, the max length for a substring that we can have is 3 with unique characters because of these strings here. ECA, CAB, and ABC again. So all that considered, it doesn't seem too hard to code up. But we just need to think about how we're handling the sliding window. Just gotta think about it. Oh, wait, that's my sound. Okay, so let's get into it. So let's say if s dot is, or s is null, or s dot is empty, just return, what would be return if, yeah, we'll just return 0. And so int max length 0. We'll say, well, the left side of the substring, right side, so we'll say int left 0, and then we'll say I'm not cheating here, but I think it's possible with a while loop and a for loop, like both, but I feel like, yeah, if I look, it is cheating, so I'm not gonna look, Also, let's initialize the hash map, so let's see, or the hash map perhaps is set, so let's say set character, C equals to set. Say for int right is equal to 0, right is less than s dot length. S plus plus. There's something wrong here. It left is 0. Ah, there it is. Figured. Let's format this. Okay. Yeah, okay. It's making sense now. So we want unique characters, so this should be starting here, right? No, we still started here, I guess. Let's say scene dot add desktop character. That's right. So we add the character at the right, and then let's add our actual if condition. So we want to say while, like what we did in Excalibur. So while scene dot contains s dot character that's right. We want to remove. We'll say scene dot remove s dot character at left and say left plus plus. The right's going to be moving up anyway, and we also add everything that's at the right. So then we also update max length. So then here we could say max or yeah, okay, we would update it here, right? So we say max length is equal to the max of max length and right minus left plus 1. And then here we will just return max length. Even if it's wrong, I'm sure it's close. Okay, cool. Gotta have more confidence. Seems like nothing. We're not going wrong anywhere. At least badly. We're not going badly wrong. Yeah, okay. Nice. Okay. Yeah, I'm gonna call it here because it's 3 a.m. or even half 3. So